warm-up, I had you, I gave you 3 coordinates and you had to figure out a fourth. Some of you are panicking. Oh my gosh, the distance formula. But what really did you use to figure out where that fourth coordinate was?
Counting.
I just guessed.
Okay, what were you counting?
The other dot.
The slope.
Thank you. The rise over run, the
That's what I was-
slope. Okay, let's talk about why that was a strategy for the type of problem I gave you. Why was counting slope helpful?
Because if the parallelogram is going to be the exact same slope on both sides.
Okay,
So-
if we have a parallelogram, both sets of opposite sides are parallel. So both sets of opposite sides would have the same slope. Okay, so today our goal is to go backwards. Is this a parallelogram? If it looks like this, does it meet the specifications? So here are our rules to know that yes, it's a parallelogram. Okay, so what page did I say? We're on page 421. Okay, so the first theorem, if both pairs of opposite sides are congruent. Yes, this is what I'm saying. If I give you a parallelogram, how about this? I give you a quadrilateral. And the only piece of information you know looks like that. Then we can say, yep, that's a parallelogram. And then we know that the sides are parallel, the angles are congruent and supplementary, all of those things, okay? But if we just have the knowledge that both pairs of opposite sides are congruent, check, it's a parallelogram, okay? If both pairs of opposite angles are congruent, then we know it's a parallelogram, okay? Let us draw a picture there. If we have a quadrilateral, oh, come on, draw me a nice one. Okay, and the only thing that is marked is this and this. Then I know, yep, that quadrilateral is a parallelogram, so everything else will hold. Now I know opposite sides are congruent. Now I know opposite sides are parallel. Would you like to get a drink?
No problem.
Okay. Okay. Okay, if the diagonals bisect each other, then we know it's a parallelogram. So if my only piece of information is something that looks like this, then we can say, oh, okay, that purple quadrilateral is a parallelogram because the diagonals bisect each other. And now we know we have opposite sides congruent, opposite sides parallel, opposite angles congruent. Okay. Now, here's the one that you maybe wouldn't expect from our conversation yesterday. But if we take just one pair of opposite sides, and that one pair is parallel and congruent, then we have a parallelogram. So let me show you what that would look like. Maybe. So if I just take one pair of opposite sides, and that one pair is both congruent and parallel, then we know, yep, we have a parallelogram, okay? What is that?
It's like a game.
Okay, just put it away. Okay, so is this a parallelogram? But I don't see parallel sides. How do you know?
It's 7.9.
Okay, yes, this is a parallelogram because both sets of opposite sides are congruent.
Water.
Yes, please go. What? I don't understand what's happening. Just shut your mouth. Okay. Is this? I said, shut your mouth.
Sorry.
Jeez. Is this a parallelogram?
No.
Why? But these like add up to 180. Okay. No, our opposite angles are not congruent. Okay. Okay. So a big part of your job today is to take a picture, whether it's labeled with numbers or dashy marks, okay, or parallel marks. Is this quadrilateral parallelogram? Okay. Another part of your job today is to say, okay, we're on the next page. Here is a picture, make it be a parallelogram, okay? And honestly, this is not going to feel much different than what we did yesterday, okay? Instead of me saying, hey, this is a parallelogram, it's me saying, hey, I want it to be a parallelogram. So if I'm going to find x, what are we going to do? 7x equals 56, right? Okay, and if 7x equals 56, what's x? Okay. Okay. What theorem are we working with here? Opposite angles are congruent. Okay. Now, if we want to find y, we need 4y plus 4 equal to 5y minus 26. Is that the only way we could find y? What else could we do, Lucas? I heard your voice first.
4y plus 4 and then plus 56 equals 100.
Okay, we could totally add these together to be 180. Okay, but we're going to set them equal to each other. So if 4y plus 4 equals 5y minus 26,
Y equals 30.
y equals 30, just plain old 30. So when x is 8 and y is 30, the quadrilateral is a parallelogram. Cool. Okay. Now, what I would like you to do, I would like you to take this mosaic pattern and could you please find me x and y so that it is a parallelogram and then choose the theorem that you're using in order to find x and y.
Is the parallelogram like the black in the middle?
Yeah, it's like green. Mm-hmm.
Kansas are you from?
Southwest Kansas, Garden City. Anybody heard of it?
Like from O'Block,
How many people?
From what?
the Parkway Gardens.
Parkway. How many people live there?
Did you just say from Oak
Like 40,000. If this is the state of Kansas, right? And this is Nebraska.
You messed Nebraska.
Actually, didn't know that.
Nebraska brown grass.
I didn't know we were
This
around
is,
Yeah, Nebraska.
are you serious?
I thought we were.
This is Garden City. This is Kansas City. This is the
Where's
Topeka,
What's it called? Blue Valley. Where's Blue Valley?
Kansas City.
I go there every Saturday.
Is there a garden
Practice.
in the middle of the city?
Okay, has anybody, you wouldn't know the book, just kidding. There is a book written by Truman Capote called In Cold Blood, where he, no you didn't, him and Harper Lee was his friend. What did Harper Lee write?
Oh, I heard
To Kill a Mockingbird.
Oh.
Okay. Truman Capote came to Garden City and wrote about a murder that took place.
I remember this really well. That was a pretty good book.
Garden City. And this is Omaha. And so, yep. Also, this is the interstate. This
How
is
far's the drive?
the interstate.
6 hours?
7 hours. Okay. So I did not grow up along an interstate where it was like easy to get to things.
That makes no sense.
What?
How was like interstates ever? I was like,
Okay.
Texas is only 10 hours away. That's what's good.
So then, okay, here is, let's see, Oklahoma, and then Texas. That obviously looks like Texas.
Oh my god, that looks so much like.
I know. So like, I was only an hour from Oklahoma and an hour from Colorado. So like, I'm very familiar with the panhandle of Texas and Oklahoma. Okay.
Isn't that where all the gangsters live? Like,
Thanks for giving us your
that's where they sell pins, like,
Okay. Go ahead and take a little walk. The gangsters?
yeah, there's that like strip where there's like no laws for the like gangsters, like cowboys.
You know how long ago that was? There was no laws there until like the 90s.
Clap back.
Hey, do you think that that's appropriate to do?
Do what?
Put your hands in your lap. Okay. What is the value of x?
I know what
3? What is the value of y? And which of these 4 did you use?
I already said it. I said it first.
I didn't use it.
Okay. Goodbye.
What was the third one?
Okay. Now, here's where the fun comes. Okay, next page. We can use the distance formula, slope, and the midpoint formula. I really should say or. To determine whether a quadrilateral is a parallelogram in the coordinate plane. So let's just write a couple of reminders down. The distance formula is when we take x minus x squared and y minus y squared. Right?
No, that's not a quadrilateral.
Huh?
Also the one below it. That's not one.
You don't think so?
No,
Okay.
I already did it.
because the slope is.
Yeah, the slope.
Okay. We could calculate slope, and remember slope is rise over run. If you don't have the coordinates drawn out, you would actually have to calculate y minus y over x minus x. And our midpoint formula, do you even remember that?
You just
Add the x. There you go. Add them. It's the average. Divide by 2.
I used the slope formula.
Okay. So in the warm-up that I gave you, where I really didn't give you any like pre-teaching on, most of you counted slope, right? Count the slope, okay? So we have 4 different theorems that we can, put that away please, we're not eating in this class. We have 4 different theorems. Okay, put it away. All 4 sides are congruent. All 4 sides are parallel. Well, okay, let me back up. 2 sets of opposite sides are congruent. 2 sets of opposite sides parallel. Diagonals bisect each other. 1 set of opposite sides are parallel and congruent. Okay? So we can take any of those 4 theorems and decide, is this a parallelogram? So here's case number 1. I have 4 coordinates. F is at -2, 4. G is at 4, 2. H is at 4, -2. And J is at -2, -1. Okay? So, idea number 1. We could take the diagonals and find their midpoint. So, if we calculate the midpoint of G and J, so we take -2 plus 4, cut it in half, -1 plus 2, divide by 2.
I'm getting delivery. I'm just
Oh, okay, go for it. Yeah, I was just
I
confused.
awkwardly did this way instead of that way. Sorry.
All right, what's our midpoint? Okay, seriously, what's 4 minus 2 divided by 2?
1.
Thank you. And 2 plus -1 divided by 2.
1/2.
Okay, there's midpoint number 1. Okay, midpoint number 2, FH. Okay, FH, we're going to take -2 plus 4 divided by 2.
1.
What is that? 1. And then we're going to take 4 plus -2 divided by 2.
It's 1.
Negative.
How'd you get negative?
She was just joking with you. Who felt it? Just Johnson?
A plant and a coffee.
Because I keep forgetting it.
Plan?
Yeah. I left it at home.
If these two are a parallelogram, what would be true about their diagonals midpoints? They would be the same. Since they are not the same, it's not a parallelogram. It's not a thing. Okay? Now, I also want to talk about the other ways to do this. So we're going to go down here to this chick picture. Okay? Write this with me, please. A is 3, 3. B is at 8, 2. Check me.
Yeah.
C is 6, -1. And D is 1, 0. Eh? Yes, no? Maybe so?
Yes.
Okay. So here's what's going to happen. We have already gone through what it looks like to see if the diagonals bisect each other. Okay? This is what I want. I want the red. Where's the red table? There. The red and the purple table. I would like you to find all 4 slopes to see if these are a parallelogram. I would like the green and the teal tables to find all 4 distances to see if these are a parallelogram. And then, what's left?
Midpoint.
Yellow and blue. I would like you to just pick one pair of opposite sides for slope and distance.
What?
We already decided we could do that. Okay? So, it's work. So, like, if you're the yellow or the blue group, you need to pick either A, B, and D, C, or you pick A, D, and what did I be? This. Pick one pair.
I'm doing AC.
Oh, yeah, you're right.
What? Oh, we do slope and distance?
Just like, look at it. This is a parallel area.
I will keep you checking.
Okay, so you can't just say, looks like it.
Like,
You
I
need to
would
give
go-
me solidifying proof.
So we
I would do this one as like one pair.
Okay, and you know what? So here's what I would do. If I was doing this one, I would not have used midpoint. I would have said the slope of FG and the slope of JH are not the same. Therefore, they're not a parallelogram. But I would use numbers. 1, 2, 1, 2, 3, 4, 5, 6. So negative 1/3 does not equal negative 1/6.
So what does the slope have to equal the one that it's done?
Like this slope and this slope have to be the same. This slope and this slope have to be the same.
How would you-
Opposite sides.
How would you find like the angle if you know the slope of two lines?
We don't know the math for that yet.
Oh.
That's kind of what we were talking about the other day with like law of cosines, law of sine stuff.
There we go.
Yeah.
When will we learn it?
Not this year. Are you calculating anything?
It's parallelogram.
Square root of 13, square root of 13.
I have 3 over 2 in the measure form.
And so the distances are the same.
It's going down.
A, B, C, C.
Wait, which one did you slope for? Is it any two parallel?
Okay, you need to pick one set of opposite sides.
Okay.
Yeah.
And then do the slope for those.
Slope and distance.
Yeah. I just want to see it.
Yeah. Or, what do you mean over?
You already found all your slopes? You've got 4 slopes?
Well, yeah.
Isn't the slope just 3-2 for ADBC?
Yeah.
I got -3, -2.
You got -3, -2.
Yeah, for
I
my
got-
slope.
I got 3 over 2.
It's just 3 over.
Yeah, 3 over 2.
If it's -3 over -2, it turns into a positive. Okay? How's our distances going?
I mean, we got it right.
Okay.
Wait.
Okay. So let's talk through this. My red and purple tables. What is the slope for? Okay, you know what? Okay, we're done. AB, what was its slope? And DC, what is its slope? -1/5, okay. What is the slope of AD? 3 over 2. And the slope of BC? Okay, so we could say, since both sets of opposite sides are parallel because they have the same slope, we have a parallelogram. Okay, now my green and teal. If we are to look if opposite sides are congruent. Okay, what is the distance between A and B?
A and B.
Square root of 26. And when we found the distance between D and C, Square root of 26. Please say it like that. What about the distance between A and D? Square root of 13, and the distances between B and C. Okay, so since opposite sides are congruent, we have a parallelogram. Okay, now the blue and yellow table. All they had to do is pick one set of opposite sides. Did you pick my green or my purples?
Purple.
Okay, so they could say, okay, we have slopes that are the same and distances that are the same. So we have one side of one pair of opposite sides. Didn't say that right. One pair of opposite sides, parallel and congruent. Okay, so you get to pick. Actually, I'm going to take that back. The textbook is going to tell you which one to pick. Okay. No, it's going to tell you which method to pick. All right. And somebody definitely erased the homework that I put up there. So it is page 425. That's where it begins. You're going to do 1 through 6. You're going to do 9 through 15. You're going to do 20, 22, 23, and 30. So if I were you, I would take the time right now to circle those. And then you can get going. It's like